Hi students, today we are discussing about the next point of vertical circular motion, that is mass tied to a rod. Mass tied to a rod. In the previous lecture we study about the mass tied to a string. That means in that vertical circular motion there are two types of vertical circular motion. The vertical circular motion which is not controlled by the gravity, that is the first type, and second type, the vertical circular motion which is controlled by gravity. That means in that two types, the potential gravitational potential energy and kinetic energy, there is an interconversion between the kinetic energy and gravitational potential energy. In that first case we discuss about the mass tied to a string. Suppose a point mass or bob which is tied to the string and it performs vertical circular motion. Suppose this is A is the top position, B is the bottom position, C is the horizontal position, or we can say that midway position. C and D are the midway position or horizontal positions. By using that expression we calculate the velocity at top position, that is equal to under root rg. That is the minimum velocity to remain in a vertical circular motion, that must be at top position is under root rg. At the bottom position under root 5 rg to remain in a vertical circular motion, and at a midpoint or midway position that velocity must be under root 3 rg. Already we calculate in previous point. Already we take the difference between tension difference between TB minus TA. These are the tension in the string. TA means tension at A point and TB means tension at B point. TC means tension at C point and TD means tension at D point. TA minus TB. TA means what? This is the tension at lower point minus tension at top position or topper position. TB minus TA means this is the tension difference between the 2 points. TA minus TB is TB minus TA is equal to tension difference between the lower and highest point is equal to 6 mg. That also we calculate in previous point. Today we are discussing about the mass tied to a rod. Now this is string, and by using that we calculate that velocities at different positions in that vertical circular motion, tension difference. But when we consider discussing about the second case, that is mass tied to a rod, that means this is a rigid rod, a rigid rod. When that bob which is tied to a rigid rod, then the basic difference between the rod and the string is that string needs tension. String needs tension at every point in that vertical circular motion, but in case of rigid rod this condition is not necessary, and that's why velocity at top position, phi minimum velocity at top position is 0 for a rigid rod. That velocity for string at top position is equal to how many? Under root rg. But in case of rigid rod that condition is not necessary, and that's why velocity, minimum velocity phi minimum at the top position is equal to 0. Same way, if we apply the same mathematics as we apply on the string, same mathematics is applied on the rigid rod. In that case, velocity at lower point, that is at point B, lower minimum velocity at lower point is equal to, is given by under root 4 rg, or we can write 2 under root rg. This is the velocity at the lower point, minimum velocity at the lower point. Same way we can calculate the velocity, minimum velocity at horizontal position is equal to under root 2 rg. These are the velocity v1, 2 and 3. These are the different velocities when we connect that, or when we tied that rod to the tied that bob to the rigid rod. In that case, velocity, minimum velocity at top position is equal to 0, minimum velocity at bottom position or v lower point, minimum velocity is equal to under root 4 rg, or we can write is equal to 2 under root rg. And velocity at midway position is equal to, minimum velocity at midway position is equal to under root 2 rg. Or how we can calculate this? So by using that similar method or similar mathematics. So in case of this, first we go for the field lower point. So mgr to mgr, this is the change in potential energy to mgr is equal to change in kinetic energy, or we can say that decrease when we move from a to b, potential energy is converted into kinetic energy, and b to a, that kinetic energy is converted into potential energy. And that's why this is the maximum potential energy at point a, that is change in potential energy, that is nothing but the change in kinetic energy. So we can write 2 mgr is equal to half m phi b square minus half m phi a square. Phi b means that is the velocity at b point, and phi a means velocity at point a. So we can solve that 2 mgr is equal to half m, we can take common phi b square minus phi a square. So this 2 goes here, that multiply 4 mgr divided by this m is equal to phi b square minus phi a square. This get cancelled, and as that phi a, that means equation this phi minimum at a position is 0, as this phi a is equal to 0, so we get phi b square is equal to 4gr, or phi b velocity at lower point, minimum velocity at lower point is equal to 4gr. Already we take here phi velocity is 4gr or 2 under root rg. Same way we calculate the velocity at midway point. So in that case also similar way, mgr, this is the potential energy at horizontal point, mgr is equal to half m phi c square minus half m phi a square, change in kinetic energy. Phi c means this point, c point, and phi a means top position. So here also mgr is equal to half m common phi c square minus phi a square, this multiplied here 2 mgr upon m is equal to phi c square minus phi a square. As phi a is equal to 0, get cancelled here, as phi a is equal to 0, that is velocity, minimum velocity at top position, phi a is equal to 0, so we get phi c square is equal to 2gr, or phi c is equal to under root 2gr or rg. This is the velocity, already we calculate here phi minimum. This is the second condition, that is when mass tied to a rod. This is the small point that is asked for 2 marks, mass tied to the string and mass tied to a rod. When that bob which is tied to the rigid rod, in that case velocity, minimum velocity at top position 0, minimum velocity at lower position or bottom position is equal to under root 4 rg, or minimum velocity at horizontal position is equal to under root 2 rg. Okay, then hi students, we are discussing about the next point of vertical circular motion, that is the sphere of death. This is a popular show in a circus. In that show, the two-wheeler rider undergoes rounds inside a hollow sphere, starting with small horizontal circles and eventually performs revolutions along the vertical circles. The dynamics of this vertical circular motion is same as that of the point mass tied to a stream, except that the force due to tension, which is replaced by the normal reaction, and that is the difference between the sphere of depth and the mass tied to the stream. The linear velocity is more for a larger circles. Linear velocity is more for the larger circles, but the angular velocity omega, which is more for a small spheres, that means at the starting or ending points. In that case we can say the angular speed, or we can say that frequency, is more for the smaller circles, and this is as per theory of conical pendulum. This is the small point sphere of death. Then the next point is the vehicle at the top of convex overbridge. This is the convex overbridge, and vehicle is at the top. So in that case also, during that motion of that vehicle in that vertical circular, this is vertical circular, convex sphere means, or convex overbridge, that means vertical circular motion, two forces which is exerted on that vehicle. First force which is exerted on that vehicle, which is weight mg, which is in downward direction, weight mg, and second force exerted, that is normal reaction, which is in upward direction, both along the vertical line, that is the topmost position. The resultant of these two must be provide the necessary centripetal force for the circular motion. If the vehicle is at the uppermost position, then we can write mg minus n is equal to mv square upon r. That means mg, which is in downward direction, minus n, this is in upward direction. That provides the resultant of these two provides the necessary centripetal force. That's why mg minus n is equal to mv square upon r. As speed increases, n goes on decreasing. As speed increases, n goes on decreasing. That means the normal reaction is an indication of contact, and therefore for just maintaining the contact, n is equal to 0, that is n minimum. This imposes an upper limit on the speed, that is phi max is equal to under root rg. Phi max is equal to under root rg. This is the second small point of vertical circular motion. Up to this is the part of circular motion. That means the rotational dynamics, which having the two parts. First part is circular motion and second part is the rotational motion. First part, that is the circular motion, that we complete. This is the last point in that circular motion. Next point or next